Hello, physics. So today we're going to look at calculating theoretical values for the lab that we did yesterday. So we can think of theoretical values as being 100% accurate no matter what's happened. Okay. So we're going to collect the same data. You can pick whatever object you want in here. So make sure that you select some kind of value here. Okay. So you're going to select some object here, a baseball, whatever. I'll pick a car. So the car's mass is 2,000 kilograms. You're going to determine that. And then you're also going to determine its weight or its force of gravity. So that'll be the first step. And then you'll then determine the amount of gravitational energy the exact same way that you did in the previous lab. And you're going to create a graph of gravitational energy on the y and height on the x. And you should have data resembling that of yesterday. So that being said, let me show you how you need to use the simulation to collect the data. So to use the simulation, you need to come down here. The first thing, let me go on the reset button. Reset. And so this is just click the intro tab. That's all you need. And this is what it'll be. So all you need to do to get this is to change because since I dropped it, I didn't have any initial vertical velocity. So I just need to take that to 0. And I can point this down or up. It doesn't matter because the initial vertical velocity, it's just dropping. So it doesn't matter. So I'm going to show it shooting down. Then I am just going to hit the fire button. Boom, fire. And so then I can take this guy and I can come down to where it collides with the ground. Make sure it's not above. Hold on, Bubby. I'm making a video. Okay, wait. Sorry, I got a kid. And then the time is what I should record. Now notice I dropped that from 10 meters. So therefore I would know the time and I would know the height. And so what you can do then is you can change the height to various things, whatever you want. So then that's it. And then you can come over here to your equation list here. And what we especially want to know is we want to know the final velocity, or the velocity right before it hits the ground, because that would be the moment where it's all kinetic energy. Do you want to sit on my lap? Okay. Say hi, Bubby. Okay. So then if we want to find the kinetic energy at the bottom, we need to find the velocity. That's why we're using the final velocity. So then this is where we have all these equations that can come into play. Remember, this is a projectile, and so when it's falling, it's accelerating. That's why on the velocity time graphs that we saw yesterday, we had a nice straight line, and the slope of those lines should have been acceleration. Yeah, that is an A, isn't it, Bubby? No, what? Oh, you're right. There is a K. So what we will use is, because it's accelerating, constant acceleration equation. One thing I want to remind you is that the acceleration is 9.8 meters per second squared. So with that, you should be able to easily solve for the final velocity using maybe a couple different equations. And that's what you're going to do. So you're going to first collect data, determine the time, use the time to figure out the velocity. Hold on, Bubby, don't touch. Use the time to determine the final velocity, and then use the final velocity to determine the kinetic energy, and from there, figure out the gravitational energy. So that's what we're going to be doing.